All right, everyone, welcome. Today, we're going to take a journey, starting from the ground right beneath our feet and traveling all the way up to the very edge of space. We're going to break down the Earth's atmosphere, this incredible, invisible blanket that really makes all life possible. So, let's get into it.
So here's our roadmap for today. We'll kick things off by understanding how our atmosphere was even born. Then, we'll start our climb up through the layers, from the troposphere where all our weather happens, to the stratosphere with its crucial ozone layer, and even higher. After that, we'll look at the massive forces that make the whole thing move, and we'll wrap it all up with a quick review to make sure you've got the key points down for your exam.
Section 1. Our protective blanket. Okay, so before we can start climbing, we've got to go back, way back, to see how this whole thing formed and what exactly it is we're breathing.
You know, the air around us today wasn't always so great for us. If you went back over 4 billion years, you'd find a planet choked with volcanic gases, what scientists call a reducing atmosphere. The key takeaway there is no free oxygen. Then a real game changer came along. Tiny little organisms in the oceans, cyanobacteria, started pumping out oxygen as a waste product. And over billions of years, this transformed our planet into the oxidizing atmosphere we have today, one that could finally support complex life, like us.
So, what's actually in the air you're breathing right now? Most people guess oxygen, right? But take a look. It's almost 78% nitrogen. The oxygen we absolutely need to live makes up about 21%. And what about that tiny 1% sliver? Well, that's a mix of some other really important gases, like argon and carbon dioxide, that play a huge role in how our planet works.
Okay, let's begin our climb. Section 2 is all about our home base, the first and densest layer of the atmosphere, the troposphere. This is where all the action is.
And you might be surprised to learn that this layer is actually pretty thin, just about 10 miles high. But get this, nearly all of the atmosphere's mass, and pretty much everything we call weather, is crammed into this one narrow little band.
Now, if there's one thing to remember for your exam about the troposphere, it's this. It's the weather layer. In fact, its name literally means region of mixing, and that's the perfect description. The sun heats the ground, warm air rises, it cools off, and sinks back down. It's just constantly churning. This layer has almost all the water vapor, so every cloud, every rainstorm, every hurricane happens right here. And all that churning and rain actually helps to clean the air, washing pollutants out.
And right at the very top of all this mixing and churning, you've got these incredible things called jet streams. Seriously, just picture them as massive, high-speed rivers of air flowing eastward at hundreds of kilometers an hour. These currents are basically the puppet masters, steering our weather systems around the globe. On to Section 3. As we climb out of the troposphere, we cross an invisible ceiling and enter a totally different world, the stratosphere. I like to think of this layer as Earth's personal sunscreen. We're now in the second major layer. You know, if you've ever been on a commercial jet, you were probably cruising right at the very bottom of the stratosphere. It extends from there all the way up to about 31 miles or 50 kilometers high.
And here's where things get really weird. Remember how it got colder as we went up in the troposphere? Well, here, it's the complete opposite. It actually gets warmer the higher you go. This is called a temperature inversion, and it happens for one reason, a gas called ozone. This warming makes the layer super stable, without all that mixing we saw down below.
So, how does that work? Well, it's this really elegant, natural cycle. Basically, powerful UV radiation from the sun hits an oxygen molecule, that's O2, and splits it apart. One of those single oxygen atoms then grabs onto another O2 molecule, and boom, you have ozone, or O3. Then that new ozone molecule absorbs even more UV radiation, which breaks it apart again, releasing heat in the process. It's this constant cycle of creation and destruction that heats up the stratosphere and, most importantly, shields us all from the sun's most harmful radiation.
Okay, time to push on to Section 4. We're going way up now, into the upper reaches of the atmosphere, the real edge of space. Up here, the air gets incredibly thin and the conditions get, well, pretty extreme.
First, we pass through the Mesosphere, and whoa, the temperature just tanks. We're talking the absolute coldest temperatures anywhere in the atmosphere. But then we hit the Thermosphere, and the temperature gauge goes wild, skyrocketing to 1,500 degrees Celsius. Now, you wouldn't actually feel that heat. The air molecules are just too few and far between. It's really just a measure of the incredible energy they're absorbing directly from the sun.
And nestled inside this super hot thermosphere is a special zone called the ionosphere.
Here, the sun's energy is so intense it actually strips electrons from atoms, creating a sea of charged particles called ions. Now, why does that matter? Because this layer acts like a giant mirror in the sky, bouncing some radio waves back to Earth. It's what makes long-distance radio communication possible. Oh, and it's also where you get the incredible beauty of the auroras, the northern and southern lights.
So, we've toured the layers, right? But the atmosphere isn't just sitting still. It's a massive, churning engine. So for Section 5, we're going to look at what drives it all. It comes down to three main forces: energy from the sun, the spin of the Earth, and our planet's vast oceans.
It all starts with the sun. The sun heats the equator a lot more intensely than the poles. So naturally, hot air rises at the equator and wants to flow toward the poles where it's cold. But it can't go in a straight line. Why not? Because the Earth is spinning. Think about it. If you stand on the equator, you're moving through space much faster than if you stood near the North Pole. It's like trying to throw a ball straight on a spinning merry-go-round. The ball's path will seem to curve. The same thing happens to the wind. This bending force is called the Coriolis effect, and it's what creates our big, circulating global wind patterns.
You know, the atmosphere doesn't work alone. Its partner in crime is the ocean. Water is incredible at storing heat, which is why coastal areas tend to have milder climates. And those global winds we just talked about, they push on the ocean's surface, creating currents that act like a giant circulatory system for the planet, carrying huge amounts of heat from the tropics toward the poles. It's a fundamental piece of regulating Earth's climate.
All right, we're on the home stretch. For our final section, let's pull everything together for your review. I want to clear up two terms that people always mix up, and then we'll hit the absolute must-know highlights from our trip. Okay, this is a big one: weather versus climate. Here's the deal. Weather is short-term. It's what's happening outside your window right now. The temperature, the rain, the wind. Climate is the big picture. It's the average weather in a place over decades. My favorite way to remember it is this: climate is what you expect, but weather is what you get.
And to make sense of all those long-term patterns, scientists classify them. The most common way is something called the Köppen system. It's pretty straightforward. It just uses a region's average temperature and precipitation to define its climate, sorting places into broad categories like tropical, dry, or polar.
Okay, let's say your exam is tomorrow. If you remember nothing else, remember these four things. 1. The atmosphere has four main layers, defined by how the temperature changes as you go up. 2. The troposphere, our layer, is where all weather happens. 3. The stratosphere has our vital ozone layer, which is like a planetary sunscreen. And 4. The whole atmosphere is a giant engine, powered by the sun and steered by the Earth's spin. Got it? Those are the absolute essentials.
And with that, our journey is complete. We've seen how this incredible, dynamic system works. But as we've learned, it's a system of constant change. So I'll leave you with a question to think about. As you move forward in your studies, what do you believe is the single biggest factor that will shape the future of our atmosphere? Something to consider. Thanks for joining me.